This meeting is being recorded.
In this video, we're going to solve sample exercise 11 from the chapter 14 worksheet on chemical kinetics together. So let's take a look at what information is given in this problem. We're told that this is a decomposition reaction of ethylene oxide, and we're told that this temperature is one scenario, this reaction, right? So we're given this temperature, we're told that it's first order with respect to our rate constant here. So this will be our values that we're going to use for our temperature 1 and our K1. And we're asked here, we're also given one other piece here. So this is our activation energy as well. So let's label these T1, K1, and EA. And this is the reaction here that we're referencing, this ethylene oxide decomposition. So we're asked to calculate the rate constant. So we'll call this K2, our second rate constant at a different temperature now, T2. So using the equation that we were given in the last video, we can plug in these values. So if you recall, that equation was natural log of K1 over K2 will equal the activation energy over the gas constant R, again in joules per mole Kelvin, or actually we'll convert that to kilojoules per mole Kelvin for this problem. And then we have 1 over T2 minus 1 over T1. So now we just have to plug in these values. And again, we're given everything we need right above. So let's take a look here how we can plug in these values, solve each step of the way, and then simplify. So first we're going to have natural log of 0.12 over K2. Right, also natural log of. And then this is going to equal our activation energy, 218, and that's in kilojoules per mole. So we're going to convert our R, our gas constant that's normally given in joules per mole Kelvin. We're going to just say that's times 10 to the negative 3 kilojoules per mole Kelvin, and everything will cancel out nicely. And then we're going to given our temperatures in Kelvin, we have T2, so 1 over 525 minus 1 over 652. So now we have all the information we need, so we can plug in some of these values. And so I tend to start over here. So 1 over 525 minus 1 over 652, depending on what calculator you use, this may or may not be easy to enter in fractions. So you can double check your answer. You should get something around this here to 3 digits, 3 sig figs. And then if we simplify these values in kilojoules over here, this is about 26,219 or so. We're going to multiply these two values together eventually. And we can then bring this problem a little further down here. And we can then plug in the natural log of 0.12. That turns out to be negative 4.423. And if we were to expand this, these two natural logs here, the way to change this operation of division is to subtract the natural log of K2. And we're going to set that equal to, after we simplify these values over here, we get about 9.7279. So we can simplify again, combine like terms. So this will cancel out. We're going to add that 4.423 over here. So I'm going to bring that over here. Now we have negative natural log of K2 equals 14.1502. We combine these. I'm going to divide both sides by a negative to give me natural log of K2 equals negative 14.152. Now, to reverse the natural log, you take the e of both sides. So I'm going to write the final answer for e to the negative 14.1502. Oh, that's supposed to be a decimal point. that turns out to be our K2 is equal to about 7.15 times 10 to the negative 7, and our unit would still be reciprocal minutes, as was with the first value for K.